So, hello guys. Today we are going to discuss wildcard masks. So, what is wildcard mask? So, a wildcard mask is simply it identifies the components, some portion of an IP address that we don't care about. So, ayun. So, a wildcard mask, it allows or denies all the traffic from a network IP address. The wildcard mask tells the router which bits in the IP address need to match the access list and which do not. So yun ang function. So what is the difference between a wildcard mask versus subnet mask? So the difference is that uh, the subnet mask and wildcard mask, they represent two different things when being compared to an IP address. So subnet masks use binary and zeros to identify the network, subnet, and host portion of an IP address, while the wildcard masks, they filter individual or groups of IP addresses to permit or deny access to resources based on an IP address. So both masks and wildcard masks are 32 bits long and uses binary ones and zeros. So technically another difference, just the difference between wildcard masks and subnet masks, is that the sequencing of the octets. So if a network, for example, a class A network is 255.0.0.0, the wildcard mask is just the vice versa of the subnet mask, so which is 0.255.255.255. Same with the class B and the class C. So the procedures in wildcard masks. So first is we have to determine the number of octets. Then we have to get the remainder and then subtract 1 from the remainder. So another example. So for our first example, we have /27. So to get the wildcard mask, we have to divide the /27 by 3. Rather by 8 to get the number of octets. So 27 divided by 8 is 3. So then we have 3 octets with a remainder of 3 because 27 divided by 8 is 24 and 27 minus 24 is 3. Therefore, the remainder is 3. So since there are 3 octets, there are 3 zeros. And for the fourth octet, we leave it blank. We have to again use the numbers. So from the remainder 3, we have to count first 1, 2, 3. So since our remainder is 3, we have to count 3 times from the left, so which gives us the number 32. For the next step, we have to subtract 1, which gives us a wildcard mask of 0.0.0.31. For our second example, we have 21. So we have to divide 21 by 8, which gives us 2 octets with a remainder of 5. That means we have 2 zeros and 2 blanks for the third and fourth octet. We use again the sequence. We have to base on the remainder, and then we have to count to 5, which gives us 8 because the fifth number from the sequence is 8. Therefore, we have 8. Then we have to subtract by 1, which gives us 7. So therefore, our wildcard mask is 0.0.7.255. So it's automatically automatically uh, the fourth octet would be 255. Anything without a wildcard mask would be left with 255. So for our third example, we have slash 14. So we divide by 8. We have 1 octet with a remainder of 6. Therefore, we have 1 0 and 3 blanks. So again, we have to count. And since 4 is the sixth number from the left, we have to subtract 4 with 1. Therefore, our wildcard mask is 0.3.255.255. So that's just how we get the wildcard mask of a network, or of a subnet mask rather. So reverse supernetting with wildcard mask. The first step would be to convert the wildcard mask. The zeros represents an octet, and get the remainder and add 1. The second step is to perform reverse subnetting. So determine the range of IP per network address covered by the address above with its wildcard mask. Since the wildcard mask is 15, we have to add 1, which gives us 16. So we have a new subnet mask of 28. Since there are 3 zeros from the wildcard masks, we have to add 3 eights. And then since 16 is the fourth number from the left, from the sequence, we have to add 4. Since there are 3 zeros, again, therefore there are 3 eights. So 8 plus 8 plus 8 plus 4 is equal to slash 28. That's our new subnet. Then we have to determine the increment. The increment here would be 16. Since from reverse subnetting, of course you have to get the increment, which gives us a subnet mask of 28, and the increment of the subnet mask 28 is 16. So we determine the ranges. We have 201.42.114 up to 15.16 to 0.31, 0.32 to 0.47. In this case, the range where the given example belongs to the second range from 201.42.114.16 up to 31. So hence, this is our supernetted network using wildcard mask from 201.42.14 up to 30. For our second example, we have a network of 168.24.62.0 and a wildcard mask of 0.0.7.255. So our wildcard mask is 7, we have to add 1, we have 8. And using the sequence of numbers, we get the number 8. Since 8 is the fifth number of the sequence, and there are 2 zeros in our wildcard mask, we have to add 2 8s and then a 5, which gives us a new subnet mask of 21. Now we have to get the range of where 168.24.64.0 belongs to. So we have to get the increment since our new subnet mask is 21, therefore we have an increment of 8. So we have the first range of 168.24.0.0 up to 0.7, and another range of 168.24.8 up to 15, and 0.16 to 0.24, and then so on. We have to get the supernetted network with a wildcard mask of 168.24.64.0 up to 0.71. So that is the range on where the example belongs to. So from our last and third example, we have 71.0.64.0 up and a wildcard mask of 0.0.31.255. So since we have 31, we have to add 1, which gives us 32. Therefore, we have a new subnet mask of 19. Since there are 2 zeros in the wildcard mask, there are 2 8s. And since 32 is the third number from the sequence, we have to add 3, which gives us. And then we have to get where 71.0.64.0 its range. So we have an increment of 32 since from our subnet mask it gives us an increment of 32. So we have a first range of 71.0.0.0 up to 71.0.31.0 up, and then 32 to 63 and 64 to 95. As you can see, the third range, that is where our example 71.0.64 belongs to. Hence, that is our answer. 71.0.64.0 to 71.0.95. And that is all.